Hello everyone, today we are going to solve another problem in chapter 6 of thermodynamics, the gas and vapor power cycle. Problem number 2. An ideal diesel cycle has a compression ratio of 17 and a cut-off ratio of 1.3. Determine the maximum temperature of the air and the rate of heat addition to this cycle when it produces 140 kilowatts of power and the state of the air at the beginning of the compression is 90 kilopascal and 57 degrees Celsius. So we have the given. The compression ratio is 17, the cut-off ratio is 1.3, and it has the power of 140 kilowatts. Temperature 1 is 57 degrees Celsius, and in this problem, we will find the maximum temperature or the temperature 3 and the rate of heat addition. So before we will proceed in solving the maximum temperature, we will need to solve first the temperature 2 using this equation. So temperature 2 is equal to temperature 1 times the quantity of volume 1 over volume 2 raised to the power of k minus 1. So since volume 1 over volume 2 is the compression ratio, we have the value of temperature 2 is equal to temperature 1 times the compression ratio raised to the power of k minus 1. So we have 57 plus 273k times 17 raised to the power of 1.4 minus 1. Our temperature 2 will be 1025 Kelvin. So we will solve now the temperature 3 or the maximum temperature of the air by using this equation. Temperature 3 is equal to temperature 1 times the quantity of volume 3 over volume 2, or also known as the cut-off ratio. So we have temperature 3 is equal to 1025 Kelvin times the cut-off ratio, which is 1.3. So the maximum temperature of this diesel cycle is 1332 Kelvin. We will solve first the thermal efficiency before solving the rate of heat addition, since the formula of the rate of heat addition is W net over the thermal efficiency. So thermal efficiency is equal to 1 minus the quantity of 1 over the compression ratio raised to the power of k minus 1 times the quantity of the cut-off ratio raised to the power of k minus 1 all over k times the quantity of the cut-off ratio minus 1. So we have 1 minus the quantity of 1 all over 17 raised to the power of 1.4 minus 1 times the quantity of 1.3, which is the cut-off ratio raised to the power of k, which is 1.4 minus 1 all over 1.4 times the quantity of 1.3 minus 1. So the thermal efficiency is 0.6597. So we'll solve now the rate of heat addition of this cycle. So we have 140 kilowatts all over the thermal efficiency, which is 0.6597. So the rate of heat addition of this ideal diesel cycle will be 212 kilowatts.